at the top of my webpage. I am doing face-to-face classes. You can come physically, a few students has, but that's normal. Usually most people prefer to tune in online. Either way is fine. The cyber competition team is forming, so if you're a relatively advanced student and taking the pen testing classes is probably the most important thing. But anyway, regardless, sign up here and apply, and the coach, our highly skilled coach Elizabeth, will determine who the team should be composed of. And if you haven't got much experience, you can still do NCL. NCL is right now National Cyber League. Anybody can do this. It costs about $30, and it's a whole bunch of really good hacking problems to solve. It's worth a ton of extra credit in any of my courses, and this is open to all people, including beginners. It's not a serious, there are parts of it are competition, but there's parts of it where you just practice. And both of those are fine. Any number of people can participate, whereas this one up here is pretty serious. We have to choose one team of just 8 people, and we can only have one team for the college, so they have to pick the top. It's like a football team or something. So only the more advanced students can get on the official team, but NCL everybody can do. And most of the people on the competition team did NCL earlier in their training. So NCL is good for you if you want to do, it's primarily aimed towards pen testing, not so much for forensics, although there are some forensics challenges there. And we also have Women in Cybersecurity chapter starting, which is helping a lot of women, and there's men are welcome too. So it's you can sign up for that if you like. Or you have a student chapter of it, and they do a lot to help people get training and move forward in the field. So those are a couple of good things to do. Anyway, what's that?
Men are welcome to.
Men are welcome to. Yeah, yeah. And so I'm the advisor. So that was my question. I said I'm not qualified. They said, well, yes, you are. Okay. So this is 121, and we're down to the second class, which is going to be Module 2, which is in the bit here. So let's talk about OS storage and such. Let's see. I think I make this big enough it'll wrap around. There we go. All right. So understanding how operating systems work is essential to be a forensic investigator. The main thing is how data is stored on various devices, so you understand how to recover it. So a file system is the method by which files and folders are stored, and files are in folders, and there's a folder structure, and there's a way to organize what parts of the disk are used and what part aren't used. And that's important because, at least in the days of magnetic media, you could very easily recover deleted files, which is the main thing forensic tools do that surprises people. And it works by this. You have allocated storage. Allocated storage is parts of the hard disk that contain a file with a name that is currently in use. When you delete a file, it does not erase the contents of the file. It just removes it from the allocation list. So the data is still there, but the file name is gone. So you can recover that deleted data. That's unallocated space, and forensic tools like the autopsy we'll be using can automatically recover deleted files off magnetic media. Now, SSDs, which are what most people are using now, often do not have any latent data. About half the time anyway, they do automatically erase that data. However, sometimes they don't, and you can recover deleted files off them too. So a byte is 8 bits that each can be 0 or 1, and that's the smallest addressable unit in memory. But on a hard disk, you have to write a whole sector at a time. It cannot read or write less than 512 bytes. The firmware will only let it read chunks of data. And typically, it's 2048 bytes on optical disks, and on magnetic disks, you typically group these together into a cluster, which is 4K. So your hard drive looks like this. Let me shrink it down a bit. You've got tracks go all the way around. Sectors are these little things which contain 512 bytes. And then you have clusters, which is a group of sectors all tied together, typically in order, and that's the actual allocation of a file goes by clusters, which is typically 4K. That means you have a lot of wasted space. If you store a file that is 5K, it takes a cluster of 4K for the first 4K and another cluster of 4K for the next one with 3K left unused. So that's called slack space. One of the many, there's extra data storage on the disk that is not currently in use, and what you will find there is leftover parts of old files. That's right, when you actually delete anything, it's not erased off the hard drive. You have to use a special forensic tool to delete it. One tool for Windows is Eraser. You can also do it with disk part clean all from the command line, but it takes hours to erase the hard drive, and that's why they don't bother. It's faster to because just like a magnetic tape, you don't need to erase it to write on top of it again. So when you save a file, it just writes on top of the old data, and that's the fastest procedure. But it does mean, by accident, that there's all this leftover old stuff there. And when criminals do bad things, they throw stuff in the recycle bin, empty the recycle bin, they think it's gone, and it's not gone. And that's why forensic investigators find, I heard forensic investigators say, it's really handy for me when somebody tips off the perp, because they throw away the evidence, and oh, there it is, thanks. I would have had to hunt for that. What did he just throw away? That's the good stuff. So, So the files, that's what we've got here. So if you have an 800 byte file, it would use 2 sectors and have file slack in the last sector if it were actually stored in the sectors. Now this example is questionable. That's why I used a 5K file. As we'll see, files under 1,000 bytes are typically stored in the master file table. They don't go to the sectors at all. But anyway, we'll get there. All right, so you examine the hard disk. The platter is the circular disk here, and a spindle in the middle, and these actuator arms move the read-write head back and forth, which has magnetic pulses that write to the disk. So that's the game. And all right. And there's disk geometry. We have number of cylinders, number of heads, number of sectors, and number of bytes per sector. But most forensic analysts really don't know all the details anymore. They used to, but now we have automatic tools that figure all this out for you, like autopsy. You don't have to actually manually recover deleted files. It will just do it for you. That's the modern technique. Now, paging is a very interesting, bizarre activity on Windows. Now, originally, like I think in the days of MS-DOS, you just had so much memory. So you'd open a program, and if you didn't have enough memory, it would just say, can't open the program. But that doesn't happen in modern operating systems. If the memory is full of other programs, and you launch another program, it will take chunks of memory and copy them onto the hard disk in a temporary file to free up memory for the new program. So you can open more programs than the total amount of memory you have. But when you go to recover some of the old ones, it'll have to be slow as it swaps memory out to move memory from the hard drive back up. So that temporary file on the hard disk is called the page file, and it contains random pieces of RAM that the operating system has moved there. Now in Windows, the page file is used in a very strange way, and I don't think anybody understands it. And one thing that happened to me is I took a forensic course, and we ran it in a lab upstairs, and we all ran forensic tools, and people found an email that I wrote to my sister 5 years before on the previous set of hardware. We had just replaced all the machines. So what that means is I was in there, I used the lab machines at that time, I wrote the email, it went in the RAM, it copied to the page file, and that must have been the machine they used to make the image to ghost all the new machines. And that copied that memory. And this guy said, remember this is a real important thing to learn. When you find something in the page file, you have no idea where it came from. It could have come from a different machine 5 years ago. It doesn't have an owner, it doesn't have a date, and it doesn't make the least bit of sense. Microsoft Windows will just randomly put things in a page file. So it is a place where data is stored, but you really don't know where it came from. And until maybe 10 years ago, typical forensic investigators would never look in RAM at all, because RAM is the same. You find something in RAM, it doesn't have a file name, it doesn't have an owner, it doesn't have a creation date. You really don't know where or when it got there. So for purpose of proving that one person is guilty of doing a bad thing, it's not worth much. Now the reason that changed is because there's a whole lot of investigations that are not about prosecuting a criminal for committing a crime. They're about intrusion detection. Somebody has hacked a network and they're spreading a virus or something, and you want to know what it is. And for that, the memory is very useful. Find out what's being done. And so it's a different goal. It's probably not going to help you prosecute an individual human, but it is going to help you understand and attack what's happened. And that's a big part of forensics. So as I mentioned last time, there are 4 related fields. Let me see if I can list them here. It's a good thing to mention. There are 4 related fields that all use these forensic tools. One is computer forensics itself, which is primarily aimed at prosecuting criminals doing bad things, like you're working for the police. Then there's incident response, which is dealing with it when your company's been hacked, figuring out not usually who hacked me, but what did they do, what harm did they do, how do I stop it, how do I clean it up. That's why I say you look in the RAM for that. Even though it's not going to help you figure out who did it, it's going to help you find out what happened, and that's usually all you care about. If you're a company, you don't really care about prosecuting them. Then there's data recovery, which is if people have a machine that has somehow lost the data. Drive Savers is the king of this. They're local. We have tours there sometimes. It's a wonderful company, and this is extremely common. The computer crashes, or it fell in the fireplace, or it fell in the water, it's not working anymore, and it was my only copy of the all-important thing. And these guys are experts at recovering it. They go on the hard drive, and they can recover everything bit by bit. It's expensive, but they can save your stuff most of the time. And the 4th one is e-discovery. These are all very similar activities, and I've got students working all these around here. There are companies doing all these things around here. And e-discovery is finding the evidence for a lawsuit. Somebody sues you, and they say, okay, you have to find all the documents about this business transaction for the last 5 or 7 years. So you have to hunt through all the servers and everything. It's, again, very similar. You're just hunting through a giant pile of data, trying to efficiently find the stuff that meets certain criteria. These are all things you do with these forensic tools. It's the textbook and stuff, they talk about it in this context, But these other jobs are essentially doing the same kind of thing, using the same kind of tools, just with a slightly different goal. Anyway, so, yeah.
May I ask you a question? It's a basic question.
Yeah.
So, while I understand, the retrieval of information, logs, metadata, etc., yes,
Yeah.
those are info that are there. But when I delete a file, I actually see that the size of the disk increases.
Right, the available disk increases because it marks those sectors available. It doesn't erase them, it marks them available. They're not erased until you save new data on top.
Ah, so then it's a fake. It's a fake deletion.
It's a what?
A fake deletion?
Well, you could call it fake, yeah. What it is, it does delete it in the sense that you can now store more fresh files. It makes those blocks available. It just doesn't erase them because that is a waste of time on magnetic media.
And when I push the delete button and
Yeah.
I hear that the RAM is running faster and faster, what is actually doing that?
Well, all it's doing is changing the master file table. All it's doing is removing the metadata, the owner and the location, and marking those blocks available. That's all it's doing. It's writing some data to the disk, but not very much. Very good. And if you actually want to clean it, it will take hours to clean the medium. That's why it takes like 4 or 6 hours. After this forensic course we had upstairs, all the students freaked out and we wiped all the drives and we found out how to do it. It's easy enough to do, but it takes a long time, which is why they don't do it automatically. It would slow down your drive. Now you can install Eraser or Steganography. Those are programs you can install, and you can set them to always clean everything that gets deleted. And that will make all the deleting slower, but of course then it will really be gone. It's just the operating system doesn't run that way in default because for a normal user, it's just a waste of time and power. Normal users don't know or care about the leftover fragments of files.
The tool you are referring to is something like the AD cleaner, the hardware cleaner?
No, those do other things. These are ones I mentioned. It's Eraser and Steganography are ones that do this particular job. Yeah. Yeah, there are probably others. Those are ones I've used. All right, and so you'll find you can turn on the virtual memory. You can adjust it on Windows machines, but it's recommended to leave it at the default value. And it's just a thing to be aware of that Windows will copy strange chunks of memory to the hard drive and back from the hard drive into memory without an apparent rhyme or reason. Anyway, so you ought to know the different formats of data, and that's why I started last time on the binary games. You should know binary, decimal, and hexadecimal, and I'll do another one of those binary games later today. I'm going to try and remember to do one every week. It's best to do just one of them a week. If you try to do it all at once, you tend to get confused. And then there's a lot of file types. And the way now, this is actually a highly questionable fact about computing technology, which I think might have been a mistake from the beginning, but in the early days, they couldn't afford very much RAM or hard drive, so every bit mattered. So they made it very efficient. And the point is, computer data is stored as bytes, and the computer does not know what they are. You have a series of 8-bit bytes. It could be text, it could be a movie, it could be an executable code, and there's no clue which of those things it is. Now, in retrospect, and some people talked about changing it, it would be better if we had like 10 or 12 bits to a byte, and some of those bits said, what is this? So you could not mix text with executable code, but you can, and that's how all the exploit development works. And so, since you can't, the file itself doesn't have any intrinsic way to mark what it is, you mark them with a file header. Typically, the first few bytes of the files are used to add some special characters to tell us what it is. So Excel files will always start with G0CF 11E0. JPEGs will always start with FFG8 and end with FFD9, and so on. And this is how, when you recover data that's been deleted, you've lost the file name. You no longer have the extension. You no longer know what it is. So this is what's called file carving, where you have a block of data you find on the disk, and you look for these file headers. And this is what the forensic tool will do automatically. It contains a list of the common file headers and footers, and it will take chunks of data that appear to be a header and footer and call it an image. And sometimes it's wrong. Sometimes the recovered images have weird stripes in them because there was extra junk in there that wasn't really part of the image. But it just found something that looked like the start of an image, something that looked like the end of an image, and called it an image. So that's a thing to be aware of. And like zip is PK, the initials of Phil Katz, the guy that invented the zip protocol, and so on. PDFs always start with %PDF and so on. There's just these, you get used to these things. If you do capture the flag contest, you'll get used to spotting these. Anyway, so the boot process. I mentioned the kernel in the news section. The kernel is the part of the operating system which is absolutely essential and must always be loaded in memory. Most of the operating system is not loaded in memory. It's sitting on the hard drive, and you only use it, put it in memory when you need it. But the kernel is the essential part that does things like read the keyboard and a mouse that has to be running all the time. So that's the core of the operating system. When you power on the machine, it executes the ROM BIOS, although now it's I think UEFI is the more modern thing. And what that does is it probes the hardware to see what you have. Do you have a keyboard? Do you have a mouse? Do you have a monitor? Do you have some kind of storage device that I can boot from? It probes to see what hardware is there. Then it finds some storage device. Then it boots from that. It tries to find code on there that's an operating system, and that's bootstrapping. Yeah, UEFI is the modern one. All right, so the master boot record is the first sector on a hard disk. And that's the master boot record, which is used to boot up the operating system. It's a standard piece of code. Then you have a partition table, which shows how the disk has been broken into segments. It's the old-fashioned system that is still used by a lot of machines, only allows you to have 4 partitions on the hard drive. Then there's a master boot code, a disk signature, and so on. This is the stuff used to boot up the system. Now, Windows supports 5 file systems, but the only one you'll ever see anymore is NTFS on a real Windows machine. No modern version of Windows is running on FAT, although floppy disks and thumb drives often are. FAT is the old system, and it was really limited. FAT12 for floppies, FAT16 for MS-DOS, FAT32 for Windows 98 and later, and there is some FAT64. I don't think I've ever seen it. But anyway, these are an older file allocation table system. The modern one is NTFS, which is mostly what you'll see. All right. Oh, exFAT is FAT64. I've seen that. That is a system that is compatible with both the Mac and Windows. And so it's kind of useful for thumb drives to be in exFAT or FAT64. But anyway, NTFS is the modern system supported by all modern versions of Windows, and it has been around for maybe 20 years. I think it started in 93, maybe 30 years. And Microsoft has been talking about for a decade or more about writing a replacement, and they just gave up. They're just going to stick with NTFS. So it's called New Technology File System. It was new in 1993. There have been minor updates, but nothing significant. So from files are compressed to save space. You can have long file names with Unicode names in them, and you have a journal. Journaling is very important. FAT-based machines like Windows 98, if it had the blue screen of death and died, if it was halfway through writing files somewhere, it would forget what it was doing. So when you boot it up again, you'd have to wait 15 minutes while it scanned the disk, and it would say, I found this stuff on the disk, and I don't know what it is, so I'm recovering it. I'm going to make a file in the root of the drive called file 000, and another one, file 001, and file 002. That's what it did, because it would forget what it was doing. Now, a journaling file system is what all the modern ones are. It has a journal of what it's doing. I'm writing a file. Here's the name. I'm writing the first block. I'm writing the second block. I'm writing the third block. Poof! The power got pulled. Now when it boots up again, it remembers what it was doing. It knows what that stuff is, and so it doesn't get corrupted as much. All right. Alternate data streams are something you don't hear much of. This is a Windows feature for compatibility with Macintosh. Apple was first with music and movies. And with music and movies, you buy a CD, you play the music, and then they want to have the art and the liner notes for the music. So there are multiple streams of data from the same file name, and that's what alternate data streams are. Anyway, modern machines use the master file table. This is the location where it stores the metadata, the name of the file, the owner, the permissions, and the sectors that you can go find it on the disk. This is like the index to your drive. And when you delete a file, it just removes the master file table entry. It doesn't erase any of the actual data. It just releases, you lose the metadata, the owner and such. So for each entry, it's 1024 bytes, 1,000 bytes to store the information about each file. And there's a lot of information here. You see it's got standard information stored here, listing the clusters, and so on. All right, prefetch files we'll talk about a lot. This is, the whole science of forensics is based on the fact that computers record everything you're doing, and they do it kind of by accident. You can turn on journaling and auditing to log what the users are doing, like we were talking about in the news segment, but normal computers are not doing that. What they're doing is they're just trying to run efficiently. But in order to run efficiently, they do, coincidentally, keep a lot of records of everything you do, which is why forensic examiners exploit this. They find the records that are kept, and the prefetch file is an example of this. Around the time of Windows XP, the amount of RAM on computers went up to like 2 or 4 gigabytes from much smaller numbers in earlier operating systems, and most of the time, you didn't have any use for that memory. It was just sitting there, and Microsoft said, this is a waste of time. What we're going to do is we're going to add prefetching. So it's going to record what programs you've been using, And when you're not using your machine, which is most of the time, you're like reading a web page, the machine is just sitting there, while you're not doing anything, we're going to fetch the programs you're likely to use and load them up in RAM so they're ready to go in case you use them. That's called prefetching, and this prefetch folder is very handy therefore. It lists the last 128 programs that have been launched on the machine and when they were launched and who launched them. So you can see what people have been doing. Now, like I say, the purpose of it is to make the machine faster and more responsive to the user, but the side effect is leaving a trail for the forensic examiner, which is the case of all the things we're talking about. They call them artifacts. These are records left behind by what you did. That's why if you want to do something on a computer and you want to lie about it later, you're in big trouble. You have to know what you're doing, because if you delete the files, they're not really gone. If you throw the machine in the fire, it's not really gone. If you throw it in the lake, if you run over it with a truck, it's not really gone. Driver savers can get it back. People think they're removing it. Now, if you grind it up in a wood chipper, that would do it. But the average thing that a clerk will think to do, like I remember one guy said, one of my forensic teachers said, I had a case, I examined this machine, and I saw a record, there's another machine. So I went to the lawyer and subpoenaed that other machine. She said, oh, I'm sorry, I sold that machine to my lawyer, and she reformatted it and reinstalled the operating system. They said, we got you. I said, no, that's fine, I want it anyway. That's not going to erase the data. That's when they just settled the case. They said, we're screwed, because they also think that reformatting and putting an operating system on again is going to destroy the data, and it doesn't. It just overwrites the part of it you need for the operating system, and the rest of it is still left there. So, that's the thing. So the prefetch files are just here. There's these little PF files, and these contain information about all the things that have been launched, like Adobe, something's been launching, and so on. All right. Then there's superfetch files, which are a strange thing in Vista, and I don't really get much good out of them, but shell bags are useful. Here's another thing. If you open a window on your Mac or on a PC, like open this window down here, it's got this view and it's in that location. Now, if I turn off the machine and open this window again, it'll appear in the same location in the same view. It remembers where all your windows are and how you like them. That's what shell bags do. They provide the user viewing, but that means it's a record of what you had open. So again, just like the other one, it's just trying to make it more convenient for the user, but that means it's recording what you did. The shim cache has binaries that have been viewed but not executed. And all right, and these are all part of the registry. Now, in Linux, there is no registry, and every program has its own parameter list. If you install something like Apache web server, it has some configuration files that list like what folder is it that the files come from, and are you going to allow people to see directories and all kinds of parameters. It has a special parameter file that comes with the software, just a text file that goes to the software. This is the way MS-DOS was. But in Windows 95, Microsoft invented the registry. They said instead of having every program have its own individual customary proprietary text file to store the parameters, we're going to have one central database of all the parameters on your Windows machine, which is your background color, the things on your desktop, all the settings for all your programs. That's the registry. It's a binary database of all those settings. It is very strange. Microsoft is a fantastically illogical company. If you study Linux. Linux was written by mathematicians. It's logical and clean and easy to understand if you have a mathematical point of view. Microsoft seems to have been written by a bunch of MBAs, business administrators, that just cared about accomplishing a business goal and didn't really care about logical consistency, so it's very strange. But though you get used to it. So the registry is in 5 root hives. HKey classes root contains the association between file name extensions and programs. So it knows DOC files or Microsoft Word files and so on. HKey current user contains the profile for the current user that has logged in. HKey users contains the profiles for all the users that could log in. So HKey current user is in fact just a pointer to a subset of HKey users. These 5 objects are not 5 independent objects. They're kind of interleaved. HKey local machine is the one I described. During boot up, your machine probes, the processor probes to see what hardware there is, because you might have turned it off and you might have done something like add a hard drive or change the keyboard or monitor. So every time it boots up, it probes to see what hardware it has, and it builds this thing, HKey local machine, which stores what is the current hardware attached to this machine. And then HKey current config contains information necessary during the startup process. A lot of things are stored here. We'll use it quite a lot. So these are the 5 root hives, and they appear in regedit as 5 folders with subfolders, but they are not really 5 independent folders. They're not really in this structure. They aren't even stored as 5 files on the disk. They're stored as about 14 files on the disk, all in different locations, and you will go through this a lot in this class. This is real important for a forensic examiner. Tons of goodies are in the registry, and the registry is a fantastically ridiculous, disorganized mess, and you just get used to it. It is not remotely logical, but it's been the standard for Windows for a long time, and you get used to finding things in the registry. At first it's confusing, and you get used to it. It's, anyway, so the different versions of Windows have different features. Vista has automatic defragmentation. This is another thing. A lot of people believe defragmentation will clean the disk, and it doesn't. It doesn't move enough files around to make that much difference. A Ready Boost was a ridiculous thing. It doesn't even matter, but the volume shadow copy matters a lot. There's now automatic backup of files on Windows machines. It stores previous versions. It has a part of the hard drive set aside for that, which is fantastic. Even if somebody modifies a file to take away the bad part, you can go to the old versions and see what it was before they modified it. By the way, Dropbox is fantastic. Dropbox, if you pay for the enterprise version of Dropbox, it stores 30 days of previous versions of everything. So even if they burn down the house and grind their machines, you get a subpoena to Dropbox, all their data is there for the last 30 days. It's bloody awesome. This is true of clouds, also iCloud. iCloud is the backup of everybody's phones. So subpoenaing cloud services is incredibly valuable for investigations. Then even if the hardware is gone, it doesn't really matter. All right, Hyperfile contains the hibernation. This is the copy of RAM used when they hibernate the machine, when they shut it. So that might have what they were recently using. Windows 7 has biometric framework, so you can log in with like thumbprints and faces. It has task jump lists, like everybody has them now. You can point to an application down here and right-click it and see the recent files you've opened in that application. This is called jump lists, and it came out in Windows 7. It's on the Mac too. And of course, that tells you what they've been doing, which files they've been opening in each of these programs. You got backup and restore, of course. You got BitLocker, which can encrypt the hard drive, and it can encrypt removable devices, but it's often not turned on. When it is turned on, a whole lot of this stuff isn't going to work anymore. If the hard drive is encrypted, you can't get in unless you can somehow find the key, which usually you can't. That's why this is what the FBI calls going dark. As more and more people encrypt their hard drives, that evidence is effectively lost to investigators, and therefore the FBI is always pushing to try to stop you from using encryption. And in fact, the guy that made Telegram, Pavel Durov, I think, just got arrested in France, and what he's accused of is providing an encrypted messaging service without registering it with the government. In France, you are required to register an encryption service you provide because of this reason. They don't want criminals using it, and they want to limit how much encryption you're allowed to use. Now in America, they haven't limited it, although I mentioned they tried back in the 90s to limit exports of it. But anyway, a lot of people would rather not have people using encrypted hard drives, but of course if you don't, then criminals can get in. It's better in general, I think, for people to encrypt stuff. It protects you, and law enforcement has other ways to get it, like those cloud services and all the surveillance cameras everywhere. But certain evidence is getting hidden by encryption, and they do complain about it a lot. USB devices, touchscreens, sticky notes. Here's some registry hives. Here's the hive files. Here's where it's actually stored in System32 config, system SAM security software, and then a separate ntuser.dat file for each user that logs in. So when you log in, your preferences go up there. And we'll go through this in great detail later there's lectures just on the registry and projects where you dig through the registry to get used to it. You need to do this not only for forensics, but also for Windows tech support to fix problems. If you don't understand Windows systems, you really have to understand the registry. Event Viewer lets you look at the Windows logs. Windows keeps extensive logs of everything, but they're not auditing surveillance logs. They're not intending to watch what the user is doing. The purpose of Windows logs is to help when the machine breaks. So they keep track of errors and things going on. And so that's one place you might find some good stuff, although usually nothing of forensic value is there, except perhaps for instant response to show you what software is being launched and such. If you take the instant response class, which I taught last semester and try to teach it in a future semester, we install a product called syslog, which creates additional logs that are much easier to understand. It just logs every process that's launched, every user that logs in, every file that's created, and that's extremely handy for instant response. It shows you what's been happening. The default Windows logs are very noisy and hard to understand. If you just open a folder and open a notepad file, it makes like 150 entries in the log. Little tiny entries that are hard to understand. The logs are pretty impenetrable, although for Windows tech support, I used to give this to students as homework, analyzing what's in the event log is a good research project. And a typical Windows machine has hundreds of errors in the event log. It's such a complicated machine. It has 1,001 uses, and you only care about 10 of them, so bunches of it are broken all the time, and you don't know. If you look in the log, you'll find all kinds of little pieces of Windows that are broken, and it can take a day to figure out what they are. Anyway, web browsers are the number one application everybody uses all the time. I'm using one now. This is pretty much what we spend our life doing, looking at browsers to look at the internet. And they keep a lot of records of what they're doing. And so getting the data from browsers is also part of the forensic tool, the favorites, the recent history in the browsers, and so on. And it has various ways to group files together on Windows machines by date or name and such. And all right, Windows 8 didn't change anything too much except make it really hard to use. And Windows 10 is the most popular one people are using now. And the main change is people finally quit using Internet Explorer, and now we use Edge. Although most of us use Firefox or Chrome or something, but anyway, Edge is the default browser. All right, and there's this thing called Cortana. I think Microsoft finally abandoned this now.
It's been deprecated, yes.
Yeah, I think and that's their so-called voice assistant to help you, like Alexa and whatever it is on the iPhone, Siri. These things are all pretty useless, you know, all the smart speakers and everything. They came and went. They're kind of a fad. Most people found they didn't accomplish enough good. But they're probably coming back in a hurry with Apple Intelligence. Apple Intelligence is coming on the next iPhone that will have an AI to help you that can see all your data. And yeah, that will be interesting, perhaps helpful, perhaps have interesting security and forensic consequences. And Microsoft has their version of that called Microsoft Recall, which they tried to roll out with Windows 11, and there was a huge uproar from the security community. Said, this is insane, this is going to expose our data. And so Microsoft didn't roll it out yet. They're going to more cautiously roll it out, but they really want to roll it out. And for forensic examiners and criminals, Microsoft Recall is a godsend. Microsoft Recall will take a screenshot every 15 seconds to see what you're doing and record all your keystrokes and all your files and save it like for 3 months in a database that is, in fact, it turns out, not very well secured on the machine, although Microsoft said it was. So they said, they're just going to put a keylogger on every machine for me. How handy. And they're going to connect it to an AI, which will have security vulnerabilities. I teach machine learning sometimes, and you can trick AIs into telling you what they shouldn't tell you. It's called prompt engineering. It happens all the time. The AI is stupid. It doesn't know. When you say, oh, the security policy has changed, I'm the administrator, you don't have to keep that secret anymore, it'll believe you. It doesn't know that you're not the administrator. You can just tell it to violate the security policy and it will hand out the secrets. So anyway, Microsoft is not going to roll it out, but Apple is. And we will see how the Apple AI, Apple Intelligence service, whether it turns out to be useful or not. But it's basically the latest version of Siri and Cortana and all these supposedly helpful services that haven't really done much good yet. Let me check for Twitch and see if there's comments. I feel the BIOS acts as a minimized Linux. Well, yeah, it is assembly language. It's not really Linux, but you know. And DD is good to copy drives. Some scam phone calls. Ask who taking their phone calls to open your Windows Event Viewer to scare them. Yes, you can do that. If you open Event Viewer on a Windows machine, it will show 100 errors. You can say, oh my God, you're infected. You need to install this tool and let me clean your machine. That's a common scam. Because, you know, it is kind of shocking when you first look at it. There's red X's and errors and stuff. It's you know, it's a complicated machine. It has 1,000 uses that you're not using. So a bunch of features are broken all the time and nobody cares. But, all right. So I'm going to stop the recording.
Can